Okay, so from uh, from yesterday, we just kind of talked about a few things that we would be discussing moving forward, and perhaps some of the expectations, uh, what we would hope that would take place this year. Um, Probably the biggest thing: get here, everyone move in the same direction, do what we're told, make things easy on yourselves. That's the best way to be successful. And I think you people agreed with that. I think that's the simplest way to be successful in any curriculum. Okay? So, regardless, we will continue. Well, I shouldn't say continue, we're going to get started on what it is to be talking about different types of cells then. Okay? So if we were to, let's say, perhaps start at the top of any organism's level of, let's say, uh, organization, you have an organism, and we'll, of course, just use humans as an example, or you could use mammals, that for us, does anyone think you know about how many organ systems are in an organism known as humans? A little higher, a little higher, a little lower. A little higher. Now you got about 11. Now, some of that may overlap with one another. For instance, how many of you still have your tonsils? And maybe some of you aren't aware of, okay? And sometimes what do I want to say, the way that a doctor may approach that, it used to be take them out, no, leave them in, then take them out. Now um, they're possibly leaving them in again because you all just said we still have them. The reason I say that is your tonsils also have a secondary role in your immune system. Okay, so uh, with that, we start with having the immune system and the lymphatic system. Those two kind of work together. So maybe you would classify them as the same one or two different types. And then some of your more recognizable systems, nervous, integumentary, digestive, reproductive, uh, circulatory, respiratory, endocrine, and I don't know if anyone's keeping track. I can't remember if I said skeletal, urinary. So we're getting up there in numbers. So then, what is it that makes all of those organ systems? Well, then it's going to be tissues. There's basically four types of tissues: skeletal, muscular, epithelial, nervous. And then it's the different types of cells that make those types of tissues. So being multicellular means you can have all these different types of cells that are going to have various functions. You would not have an epithelial cell that would have the same function as a muscle cell. Because when you think of a muscle cell, its major function would be what? Yeah, it's going to be movement, whether it's going to be, let's say, smooth muscle that's type of involuntary, like in the walls of your arteries, your veins, the lumen of your small intestine that takes place of, uh, has something to do with digestion. So that's squeezing all of those chicken nuggets that you consumed through your digestive tract. Then, of course, voluntary or skeletal muscles that do that just move the skeletal system, and then your cardiac muscle that works with contraction of your heart. Okay? So you wouldn't want to have muscle system cells having the genetic material of that of skin cells because they have two totally different corresponding functions. Okay? And what we mean by that is some of you, because I think it had affected myself last winter, okay? Does anyone think they know what the skin has to do with taking in sunlight and producing energy? It's a specific vitamin that we need. It's vitamin D. That's right. So if it's cold, dark, and dreary outside, that has something to do with your energy level. You just kind of feel, I just don't feel very, and like I said, I'm guilty of that. Maybe some of you maybe felt the same way, that it's awful out here, and January might not have been too bad, but February and March really weren't that fun. I mean, 11, was it 11 snow? No, 13 snow days, okay? And some of you maybe thought that was great, but then on that backside where you, I'm not saying upset, but think, gosh, now we're in here till May, what was it, 23rd for you people? Was that awful then, or not so bad? Or could not care less? Okay. So how does a person go about saying that? Oh, I could care less, or do you say I could not care less? Like the sophomores are in here now. Oh, I could care less. Or the sophomores are in here. I could not care less. Couldn't? But do you believe that? Could care less. Do we believe that? Could not care less. So if you're raising your hand, maybe you believe that, maybe yes, maybe no. But we won't say one. We're just using that as an example. When you're talking about something and you really don't care, you could say, oh, I could not care less. Okay, so what do cells have in common? Well, sometimes it's their shape, okay? That's going to correspond to their function. And one of the things you'll see either on Thursday or Friday, we refer to what are these cells doing in animals' survival. And of course, there are various aspects that deal with an animal's metabolism. So when we look at like snakes, frogs, cattle, or humans, okay? Who are the top two metabolism winners that has a very fast metabolism? Do you think? Okay, so we said snakes, frogs, cattle, or humans. Who's got the fastest metabolisms? Half right, half wrong. If we look at the progression of, we want to call it animals in the animal kingdom, when we talk about the five most complex, okay, that being fish, reptiles, amphibians, birds, mammals. Okay, let's look at it that way. Okay? Who's got the fastest metabolism in that regards? As evolution, or if you want to call it intelligent design, pick these animals to look the way they do, okay? Who's got a fast metabolism and a slow? Again, fish, amphibians, reptiles, birds, mammals. Who's got a fast metabolism? Mammals and birds. Okay? Now, whether you consider humans as mammals, whichever, I mean, that's fine. Why is it that the birds and the mammals have such a faster metabolism than that of fish? Sharks eat a lot, too. But do they eat as often, though? No, because their metabolism is really, really slow. Okay, so then you move on to that of amphibians, which have to be tied to water. But how many of you have been to western South Dakota, and in the summertime, better be careful for these things with diamonds on them? Rattlesnakes, okay? So typically early in the morning, you might see them out in the sun. What are they doing? Yeah, they're sunning themselves. Why? They're cold-blooded. They need to warm up their core body temperature. Only way to do that is if you're the same temperature as your surroundings, is absorb that sunlight. Okay? All right, so the reason we mentioned that, okay, so if birds and mammals have the fastest metabolism, which they do, okay, you have to have a way to extract as many nutrients from your diet as you can. And for birds and mammals, where does that absorption of nutrients take place? It's not the stomach. What's a better word for the gut? Too far down the road. The small intestine. Okay? So what happens is, I don't really have the, I was trying to explain the A&P students, okay? If this is a cross of your small intestine, okay, it's nice and circular and spherical, if you want to call it that, okay? If food or the nutrients that you're trying to take place is going through a circle like this, there isn't much of a surface area to absorb all that protein, carbohydrates, lipids, and fats, and nucleic acids. But if you had a whole bunch of tiny projections, like picture this paper clip, it's going all the way around and sticking up inside that gut, you are incredibly increasing that surface area. Okay? The reason that's important is if you have a bigger surface area, you can extract more nutrients. Okay? So when we look at this cell size, there's a surface to volume ratio that will change. That's why we have so many cells inside of us. Okay? So if we wanted to increase the surface area, if you take your fingers and like this, okay, the surface area would be going up and across like this, correct? Okay, well, there's a little more to it, but then there's front and back like this to provide that surface area. But should you take those 4 individual fingers and do that, is that greater or less? That's a lot greater. Like, for instance, I don't know, we'll just keep things simple, and I don't have 4-inch fingers, but for mathematical purposes, we're just going to say 3, 4, 4, and 3. Okay? So that's 14 inches, right? 8, 6. Okay? But now, if we do 4, 8, 6 more, okay, 14, 20, 26, 32, 36, 40. Okay? So having that ability to increase the surface area makes us as multicellular organisms more efficient. And a place that that's going to be found is inside of our cells, but especially inside of your small intestine. Okay. So one of the things that we refer to is these metabolic wastes. Okay. Some of you were referring to your volleyball practices, your football practices. And, you know, even you might laugh about this, I got sore during marching band as well. I mean, it's not as taxing on the body, but for some of you, hold out a musical instrument like this marching for a long time. Or I've never understood how flutes can do this. That has got to be sore on the body. I would agree with that. Right, but I'm not coordinated enough to do this. And then you throw in the bobbing up and down at the same time. Yeah, I wouldn't be able to do that.
It's not as aggressive, but it's
So when we talk about this soreness, football players, shoulders sore, thighs sore, probably your quads, hamstrings, calves, all of those. Okay, Volleyball players, I don't know enough about. I was just asking. Little sore in the legs, okay? There's a reason for that is because you have some of these metabolic wastes. It's not that it's accumulating too quickly, okay? What's happening is you are producing energy anaerobically, in other words, without oxygen. Because yesterday we said there are 3 parts of your body that have to have constant supply of oxygen. Brain, heart, and diaphragm. 3, not 4, 3. Okay? So, what happens then, if we had these larger cells, you could accumulate metabolic waste too quickly. But that also happens when our body isn't quite as efficient. Now, as you progress through the seasons, okay, you're going to find out, oh, my body isn't as sore as it was. Well, that's because it's making adjustments, but mainly becoming more efficient. You can run or same amount of time, same distance, same duration, but you're not going to be as sore because your body has made that adjustment and just become more efficient. And that's natural. That's why it's important to, once you get into shape, just try to stay there so it's not so taxing on the body to get back into shape again. All right. Okay. So again, there's 3 basic types to every cell. You're going to have a cytoplasm, a plasma membrane. Later on, we'll get onto the nucleus. Okay. Okay, does everyone have this information that wants it? Okay, there's just one. We're done writing. There's just one last thing I want to show you up on the board, and we'll be done for today. And again, I haven't formally assigned the vocab terms. That's something you can always get started on. Um, it would be, remember, we got 2 short weeks in a row, next week and the following week. So possibly, maybe we'll have the vocab due a week from tomorrow. I don't know. That's something I want to address at a later time, perhaps next week. Okay, so one of the things I want to show you is we're talking about cell structure and function. Okay. In miles per hour, okay, for a stimulus to get from your brain to the quad muscles in your legs, for instance, miles per hour, how fast does it take to get from point A to point B? So, miles per hour, okay, which you might think, well, that doesn't sound so great, but remember, this isn't the entire length of a mile. We're talking about less than a meter. Okay? And the reason for that is, does anyone know anything about your nervous system? There's two types of main cells. Those are called axons, and those are what we call dendrites. Okay? And what that means is they got this silly structure that looks like this. Okay? And then perhaps you could say it's a terminal, out like so. That's going to be hooked up to another one of these. Okay? So these all start shooting out and making attachments. Because what happens is we want to send a signal from one neuron to the next, and what happens is there's an influx of sodium and potassium. And you'll notice that's why you take electrolytes, correct? Gatorade, Powerade, it has those electrolytes in there that get replenished when we do something taxing on our body. Okay? But what happens is if you start depleting them, those muscular contractions aren't as efficient as what they should be because you're running low on those electrolytes. So that's why we take them in. And then what happens is, does anyone know, and unfortunately some people may know someone who has been diagnosed with ALS or Lou Gehrig's disease or Parkinson's disease? Does anybody know something like that? And what happens is, as that disease progresses, their muscular coordination isn't as smooth as it should be, and that's because this cell structure here, or this axon, starting to deplete. And what happens is, it's kind of like an electrical cord. If you have a mouse start to chew through there, that can do what to the electrical system? Shorts it out. And that's similar to what happens to the human body. It's unfortunate, but it's just one of the things that happens. Okay, that's it for today. Have a good day, people. Don't forget your cellular devices. Catch up with you tomorrow.